Hello everyone, I'm Dr. Tanmoy Biswas. I welcome you all in my channel TanmoyChem. Today's topic of discussion is on MCQ and the question is in front of you. It is actually a tetrachloro derivative reaction with excess alkali. What is the product? Four options are provided, one of them is the right answer. I request everyone please pause the video, try by yourself, and whatever answer you get please write in the comment box along with few words as explanation. I believe you have tried, so let's start. Read the question. Look at the molecule little carefully. Tetrachloro. We know that in case of halogen, the withdrawing group -I is more dominant than its plus R effect. Means halogen are overall as electron withdrawing group. Means because of the presence of this 4 halogen atom, this benzene ring is more electron deficient compared to unsubstituted benzene. And electron deficiency is the criteria for aromatic nucleophilic substitution. Means there must be halogen, I agree, but along with that some electron withdrawing group needed. Actually, if you focus on this chlorine, with respect to this chlorine, other halogens are behaving as electron withdrawing group. Okay, so this is the thing. So what will happen in this case? This hydroxyl will act as nucleophile and perform the aromatic nucleophilic substitution, or some people say as nucleophilic aromatic substitution, anything. So what will take place? That okay, it too will attack this ring and the negative charge can be stabilized with this chlorine or this chlorine. I'm not going in that details because with respect to this one, this is ortho and this is para, so they will participate directly in stabilizing the negative charge. Fine. Now after that what will happen? Again it will come back and this Cl will leave. By the way, if anyone have any doubt regarding the mechanism, I suggest you, I've already uploaded a dedicated lecture. I shall provide the link, please visit. So in this way, through aromatic nucleophilic substitution, what is got? This OH. By the way, if you look at this, is nothing but a phenolic OH derivative. And we know the phenolic OH is significantly acidic, and when you have strong alkali, actually generally this alkali means sodium hydroxide or potassium hydroxide, means strong alkali. Not only that, it is attached with 3 more chlorine atom, so you can expect, sir, it is a significantly acidic, this OH, because the conjugate base, I mean O minus, stabilized in this benzene nucleus. Not only that, the electron withdrawing effect of this remaining 3 chlorine also helps to stabilize the negative charge. So it is significantly acidic. By the way, if you want to know about the halophenols acidity, I mean chlorophenol, bromophenol, idophenol, you may visit. I have already made a dedicated MCQ on this also. Now here what happened? It will abstract this proton resulting O minus. Obviously there is a counter cation I haven't shown. Now what will happen? So in this way, you may think that since alkali is taken excess, so all this tetrachloro derivative will be converted this one. Agree? And some of them will convert to this one also, since it is a not that much strong base, weak base. So you may expect, okay, sir, there will be a equilibration. Now these will, in the next time, this will act as nucleophile. So what is the electrophile? Obviously, this mono substituted derivative. Agree? Now you can expect that okay, this will act as nucleophile, so where it will attack, the place of attack depends on the position. For example, if you look at with respect to this chlorine, para position is OH, electron donating. Okay, so here reaction probability is less. But if you look at this chlorine, yes, you can say sir ortho, but the -I effect of this OH can work here. Okay, so this is the thing. So that's why here this proton, this chlorine can be replaced by obviously again aromatic nucleophilic substitution. It will attack and I'll obviously through this mechanism it will leave. Now question, why this one? Why not this one? Actually, when you explain anything, look at what kind of option I have given. Okay, so that's actually an interesting point. Now, so okay, fine. So here it will be substituted. So one side is OH, you can see. So this part substituted, these attacks, this is chlorine. So okay, fine, another OH is here. Whatever OH, I mean this OH is there. Okay, next point. So right now look at this OH and this Cl, they are pretty closer together. So this is nothing but an intramolecular reaction, and we know that intramolecular reactions are far more favored over intermolecular counterpart. So in this case, this chlorine will be replaced, and if you look at the para position, electron withdrawing group exists. So because of under this condition it will, but by the way, what is the role of this OH? Actually this OH first remove this proton and it makes this O minus such that the nucleophilicity of this oxygen enhanced, so it will attack and it will come out. So Cl minus will come out, and in this way these molecule will produce. By the way, it's a, you may consider it's an aromatic ether. Now you may ask one question that, sir, will the reaction stop at here or it will proceed further? Actually reaction will stop at here, it will not go further. Why? With respect to this chlorine, para position, 1 oxygen. With respect to this one, 1 oxygen. With respect to this one, para position. With respect to this one, para position, 1 oxygen. Previously, if you look at it, it's a tetrachloro derivative. So all chlorine were electron withdrawing group. But right now, if you look at this oxygen is a electron donating group, means this could be donated, and here the oxygen case plus R effect is more dominant over minus I. However, in case of halogen, I mean chlorine, the minus I is more dominant over plus R. So that's why it was considered as electron withdrawing group. But if you look at here, phenolic oxygen is actually electron donating group. So from there, what is the conclusion? So okay, these chlorines are not that much electron, this ring is not that much electron deficient. So aromatic nucleophilic substitution means attack of nucleophile is not favored here. So further reaction will not take place. So this is the answer. So option C is the right answer. By the way, student, so if this question appears in your exam hall less than 30 seconds, how can you solve? First look at the position. It is 1, 2, 3, 4, 5 position. So if reaction takes place this, by the way, in between these places are hydrogen. Okay, and another thing, you can say, sir, benzene formation. Agree, but benzene formation is far more drastic condition. You recall the chlorobenzene to phenol conversion, I mean the Dow process. Okay, so here what was the reaction condition? Very high temperature, very high pressure. Okay, so even high pressure, so very drastic condition needed. Now chlorine is not that much stronger electron withdrawing group, it's not like that. So that chance is a second priority. First, aromatic nucleophilic substitution. Second thing, this chlorine atom has vacant d orbital. I know you'll be confused, that's a d orbital. Yes, it has vacant d orbital, it can accept electron density, so it can help the aromatic nucleophilic substitution. So from that point, if I say, okay, this point, if you look at this option, so what, there could be one chlorine, I agree, there could be another chlorine, so where it gone? It's a wrong option. If you look at similar kind of there, so there and there, wrong option. If you look at here, so chlorine, one option on position, okay, 1, 2, fine. There could be another chlorine, where it gone? That chlorine gone, hydrogen attached. So from these you can understand option A, option B, option D is a completely useless dummy option. So what is remaining? Option C, that is the right answer. Remember one point, student, many times we see very big option given, apparently we get afraid, okay, it may be very complicated. Sometime question, if you look at the options carefully, the options are actually wrong from very common sense. So from that point you can say, sir, okay, right answer. Maybe you don't know exact right answer, but you know wrong answer, and using the process of elimination strategy you can eliminate wrong option. What is remaining? Only option C, so it is the right answer, there is no option left. So from there you can conclude this is the right answer. It will be the major product of this reaction. Now this is the overall discussion for today. I believe you have learned a lot, and if you really enjoy the content of my channel, please help this channel to grow. And if you have any doubt regarding the logo of my channel, I request please read this part, your doubt will be clear. So see you in my next video. Bye bye.